Hello everyone, welcome to Unstoppable Reviews channel. This is Maruth HF24 trainer. This was designed and developed by HAL under the leadership of Dr. Tank. Coming to its particulars, it is having a length of 15.87 meters and wingspan of 9.0 meters and a maximum weight up to 10,925 kilograms. And it has a maximum fuel capacity of 4,772 liters. This Maruth HF24 trainer is having twin seat with twin engine trainer, and both the twin seats are having duplicate controls. The first flight was on June 1961. And it has a production from 1954 to 1977, and it has a power plant of 20703 turbojet engines. Coming to its performance, it can have a maximum speed of 1112 kilometers per hour and a rate of climb is 22 meters per second, and maximum range is 1445 kilometers. This one is MiG-21 fighter aircraft. This is also called as Frontline Tactical Interceptor. So coming to its particulars, it is having a length of 15.40 meters with a span of 7.15 meters. It is having a height of 4.125 meters. And maximum weight up to 9,872 kilograms with a fuel capacity of 4,465 liters. This MiG-21 fighter aircraft was built under license with USSR. It is having two types of MiG series, that is MiG-21M and MiG-21 BIS. Coming to MiG-21M, the production period was from 1973 to 1981, whereas for MiG-21 BIS, it is from 1978 to 1987. And coming to its power plant, R25300 turbojet engine with an afterburner with a thrust of 7,100 kilograms. This is all about information with respect to MiG-21 fighter or a trainer aircraft. This one is Hindustan Jet Trainer 36 and also named as IJT in short. Was developed for Indian Air Force. And coming to its general characteristics, it can have a crew of 2 members or a single member with a length of 11 meters and a wingspan of 10 meters. Coming to its height, 4.40 meters, and the takeoff weight is 4,250 kilograms. And maximum takeoff in weight is 5,400 kilograms. This particular IJT project began in 1999 with the first prototype for flying was on 7th March 2003. Initially, this particular flight was having an engine of large arc, and later it was replaced by more powerful engine named as NPO Saturn AL 551 engine. It is having a thrust of 17.6 kN with an engine of NPO Saturn AL 551. Coming to its performance, the maximum speed it can achieve is 750 km per hour with an endurance of 3 hours and service ceiling of 9,000 meters, and the thrust to weight is 5.59. So altogether, this Hindustan Jet Trainer 36, that is IJT, is a replacement of Hindustan Jet Trainer 16 named Kiran for our Indian Air Force. So our next aircraft is light compact aircraft, also called as LCA in short. It is having a span of 8.2 meters with a length of 13.2 meters and maximum weight 13,500 kilograms with a fuel capacity of 5,297 liters. This particular LCA aircraft was designed and developed by Aeronautical Development Agency, that is ADA, Bangalore, with the active participation of Hindustan Aeronautics Limited, Bangalore. So it's a combined project of ADA Bangalore with active participation from HAL. So it is having a single seat, single engine, lightweight, all-weather multi-role tactical fighter. It's one of the important fighter aircraft for our Indian Air Force, and it is having very lightweight. And this particular aircraft was first flight on 4th January 2001. Coming to its power plant, 1 GE F404 IN20 engine with a thrust of 8362 kilograms. This was the initial engine for this particular aircraft. Later, it has been replaced with our indigenous Kaveri engine. Coming to its performance, it is having a supersonic maximum speed at all altitudes with a service ceiling of 15 kilometers and the rate of climb is 200 meters per second and 960 meters is the takeoff distance. This is the one of the important aircraft for our defense applications. This one is Lakshya pilotless target aircraft. As the name itself is saying, it's a pilotless, so no pilot is required for this particular aircraft, and this aircraft can be reusable for multiple missions with a maximum number of 10. And this one is Ajit. It's a single seat air compact and short range ground attached fighter. This particular fighter jet is having integral fuel tanks in the center with an improved system. It's a lightweight jet fighter aircraft developed on 1980. Total 80 numbers produced by Hindustan Aeronautics Limited. And coming to its general characteristics, this particular fighter jet is having an engine that is O701 turbojet having 4700 lbs thrust at 9,920 rpm. This fighter jet is having a length of 6.73 meters with wingspan of 6.73 meters and a height of 2.46 meters. The empty fighter jet weight is 3,539 kilograms. Coming to its performance, it is having a maximum speed of 1152 kilometers per hour and it requires 6 minutes to climb 39,000 feet. And service ceiling is 45,000 feet or 13,720 meters. So this is all about Ajit fighter aircraft developed and produced by Hindustan Aeronautics Limited. This aircraft is named as Canberra. It's a multi-role aircraft used by our Indian Air Force for multiple operations like bomber, and this was used as a trainer, and also it has been used as a high altitude PR aircraft. The first flight was on 13th May 1949 with a power plant of 2 Rolls-Royce Avon 109 or Avon MKI turbojet engines. Each engine is having a static thrust of 3,357 kgs. And coming to particulars, it is having 19.51 meters span with 19.96 meters length and 24,925 kilograms maximum total weight. This Canberra is having fuel capacity of 12,569 liters with a performance of 827 km per hour maximum speed and 17 meters per second rate of climb, and with maximum fuel the range is 5,840 kilometers, and with maximum load the range is 1295 kilometers. So it's a big aircraft with multiple operations. Like this aircraft was used as a bomber. This aircraft was used for bombing operations, as well as this Canberra was used for training purpose as well as for high altitude PR aircraft. This is advanced light helicopter named as Dhruv, and it has a length of 15.9 meters, width of 13.2 meters, height 4.98 meters, and maximum takeoff weight 5,500 kgs with a speed of 295 kilometers per hour, and it can cover a range of 640 kilometers with endurance 3.7 hours. Dhruv was designed and developed indigenously with a twin engine, multi-mission, new generation multi-role helicopter for Indian Army, Indian Navy, Air Force, as well as for civil operations with good high altitude, high performance and excellent survivability. This particular helicopter certified for military operations by the Center for Military Air Worthiness Certification, that is CEMILAC, in 2002, and also it has been certified for civil operations by Directorate General of Civil Aviation, that is DGCA, in 2004. This particular advanced light helicopter Dhruv is having maximum seating capacity of 14, that includes 2 crew members and 12 passengers. It's a multi-purpose, multi-mission, a new generation helicopter for defense application as well as for civil applications. It's having a huge space for all the operations, and the main feature for this particular helicopter is it is having excellent survivability. Radar stands for radio detection and ranging. It provides positional information of an aircraft, that is range of the aircraft, angle with respect to radar, all the details it is going to provide for an aircraft. This one is an X-band radar used to detect weather around an aerodrome. This is an X-band radar used for detecting weather around an aerodrome for briefing pilots flying into or away from an aerodrome. Depending on the density of the weather, a color-coded display is indicated on the screen for pilot convenience. The radar can also measure the height of the cloud base and the quantum of the cloud. Whenever the thunderstorm clouds occurs, this radar helps to predict development and cessation of the thunderstorm, which will greatly help the pilots. So this is a very, very important device for the pilots, and when they are dealing with different types of cloud environments during their flight. So this is air traffic control radar and antenna. So in short, it is called as ATC radar and antenna. Coming to its specifications, it is working in the frequency band from 1250 MHz to 1350 MHz, and the type is G7 with a tilt of 0.5 to 5.5, having beam width of 1.25 with a gain of 32.5 dB, and the range is 200 nm with a peak power of 2 megawatts. It's a make in Italy, and type of feed given to this particular antenna is horn feed, and the height covered is 0 to 70,000 feet. It was first commissioned on 1967 and later it decommissioned on 1991. It's an air traffic control radar working in L band for surveillance, and the frequency that is used for this particular radar is from 1250 MHz to 1350 MHz with a range of 200 nautical miles, that is 200 nm. This radar antenna rotates at a speed of 5 to 10 revolutions per minute. So we are having 5 to 10 RPM for this particular radar, and the antenna is cosine squared pattern parabolic reflector with a single feed horn. We can see here the feeding structure in this particular video. It can handle peak power of 2 megawatts for a range of 200 nautical miles. This radar antenna rotates at a speed of 5 to 10 revolutions per minute, that is RPM, and the antenna is cosine squared pattern parabolic reflector with a single feed horn. It can handle peak power of 2 megawatts and a range of 200 nautical miles. As already we have seen the radar definition, radar stands for radio detection and ranging, which provides positional information of aircraft, that is range and angle with respect to radar. This is one of the most important device for air traffic control station, and this radar is consisting of antenna with the technical specifications as we have discussed earlier. This one is very popular. This is full size heat shield of a PSLV. PSLV stands for Polar Satellite Launch Vehicle. So in short, it is named as PSLV. Basically, this particular heat shield is used for keeping satellites. So heat shield is a uppermost stage of Polar Satellite Launch Vehicle, that is PSLV. It is made in two halves, cut off thin walled, intricately machined aluminum alloy panels and sheets, and weight about 1200 kilograms. The main purpose of heat shield is to house the satellites which is to be launched into the space orbit, and it provides an aerodynamic shape to the launch vehicle. So basically, this particular heat shield will be used for protecting our satellites which are going to be launched into the space orbit, and also this is going to provide an aerodynamic shape for our launching vehicle. So it protects the satellites while passing through the Earth's dense atmosphere, and the special separation mechanism which joins both halves of the heat shield is fitted with an explosive cord. That means during the process of releasing satellites into the orbit, the two halves are going to be separated with a mechanism which is nothing but explosive cord. When the PSLV reaches about 110 kilometers, this cord is made to explode, causing the two halves to separate and fall off. And the PSLV can carry satellites up to total weight of 1000 kilograms. That means this PSLV can take small satellites and satellites having a weight of up to 1000 kilograms. And the satellites are put into an orbit of about 900 kilometers height. So in order to see the glimpse of this particular construction, so please change the video direction at the center of this particular PSLV chamber, and you can find out the whole mechanical system and the structure of this particular PSLV heat shielded construction. Thank you everyone for watching our vlog. See you in the next video. Don't forget to subscribe and share our channel with your friends and family members. Thank you.